Today we get to look at motion under gravity, and motion under gravity is still straight line motion. It means that even as we are dealing with motion under gravity, we are still going to use the three equations of motion, or call them the equations of constant acceleration. The three that are very common. Of course, in our previous videos we derived 5, but there are 3 that are very commonly used. Now it is still going to be motion in a straight line. The only difference here is that our acceleration is acceleration due to gravity. Now, when dealing with motion under the influence of gravity, it is presumed, or we shall assume, that we are not experiencing any kind of air resistance. And so, because we are not experiencing any air resistance, that is, in our presumption, it would simply mean that the object is falling freely under the influence of gravity. Now, gravity varies from place to place depending on where you are on the earth. In some places, gravity is 10 meters per second. In others, it is 9.8. Now, for the purposes for this video, we shall take our value of gravity, or the acceleration due to gravity, to be 9.8 meters per second. Now, just like we had earlier derived our equations of motion, or our uniform acceleration formula, those very equations are going to be used here when we are dealing with motion under gravity, and definitely the value of A is going to become negative G. Now, where does this negative come from? We all know that because we are on the earth, we are attracted. There is a force that pulls us towards the earth, which we call the gravitational force. This gravitational force acts towards the center of the earth. Now, meaning when you are to jump from a plane in the air and you're coming downwards, as you're coming, your speed will be increasing because you're coming closer to the force of gravity. So you'll be coming downwards with a very high speed. But if you are to throw a stone into the air, it means you're throwing this stone away from the force of gravity. It means as you're throwing the stone upwards from the ground, as it moves up, it will be reducing its speed. It reduces its speed until it reaches a certain point where its speed will be 0, then it will come back down to the earth. What does that mean? It means that as you are throwing it up, the speed keeps reducing. It means that the stone is moving up against the force of gravity. The force of gravity in this case is acting in the opposite direction to the direction of the stone that you're throwing up. That is why as it is moving up, its speed keeps reducing, its velocity keeps reducing. So because its velocity keeps reducing, it means that when you are throwing a body and it is moving vertically upwards, away from the earth, it's going upwards, its acceleration due to gravity will be negative G. Why? Because as you're throwing it upwards, it is decelerating. Its speed is reducing. Its rate of change of velocity is reducing as it's going up. Yet when you throw something, drop it from up, then you drop it down, it will move very fast. When you're dealing with straight line motion under the influence of gravity, when the body is moving towards up, it's moving away from gravity, or it is working in opposition to the force of gravity that is pulling it down, and so its acceleration due to gravity will always be negative G, and as a result the equations of motion will be like this. And of course, if the body is moving vertically downwards towards this earth, towards the center of gravity, it would mean that the value of G will be positive, and so it means that these equations will remain the way they are, only that the place of acceleration is actually G, which is meaning acceleration due to gravity. So we are going to do some worked examples to illustrate how these work. So we have a question right here. A brick is thrown vertically downwards from the top of a building and it has an initial velocity of 1.5 meters per second. If the height of the building is that, find the velocity with which the brick hits the ground. As usual, we first summarize the question diagrammatically. A brick is thrown vertically downwards. So It's on top of a building, right? So we are having this being our building, and right on top here we are having a brick. It's thrown vertically downwards from the top of a building, and it has an initial velocity of that. So our initial velocity here is 1.5 meters per second. If the height of the building is that, so meaning that as it's moving down, the height of this building is 19/2/7. Find the velocity with which the brick hits the ground. Now, of course, as it's moving downwards, it's moving towards the earth, so it means that the acceleration is g. It's positive gravity. So it means the velocity with which it hits the ground definitely is going to be equal to v squared is going to be equal to u squared plus 2as. So the final velocity with which it hits the ground is what we are looking for. We shall call that v squared is going to be equal to u squared, which is 1.5 squared plus 2 times acceleration. We said in this video acceleration due to gravity will be 9.8, so it's going to be 9.8 times the displacement. Now the displacement, as it's moving from up down on top of the building, the height of the building is 19/2/7 meters, so it means that it's going to be 19/2/7 meters. So our answer will be 19.5 meters per second. That is the velocity with which it hits the ground. So part B, we are having they're asking us to find the time taken for the brick to fall. So to get the time taken for the brick to fall, using the first equation of motion, v is going to be equal to u plus at, and that's going to be our initial speed is going to be 1.5 plus our acceleration, which is the gravity, which is 9.8, times the time which we're looking for is going to be our final velocity. Of course, our final velocity we already got it as 19.5, so it's 19.5. When we make t the subject of the formula, we shall get our value of time as 1.84 seconds. Now we'll take this a notch higher. A ball is thrown vertically upwards with a velocity of 14.7 meters per second from a platform 19.6 meters above the ground level. Then find the time taken for the ball to reach the ground and the velocity of the ball when it hits the ground. Now, again, we'll summarize our questionnaire diagram. So a ball is thrown vertically upwards with a velocity of that, and it's on a platform 19.6 meters above the ground. So this is the platform we're talking about right here. This platform is 19.6 meters above the ground, and this ball is thrown vertically upwards, so it will go up then come back down. This is our ground. So a ball is thrown vertically upwards with a velocity of 14.7 meters per second, so it means it's going upward with a velocity of 14.7 meters per second from a platform that is 19.6 meters above the ground. This is the ground. Then they're asking us to find the time taken for the ball to reach the ground. So it means that the ball goes up, then it comes back down to the ground. How long is it going to take for it to move from here up to there? Now let's try and first of all analyze the parameters. Before we answer this question, let's analyze the parameters in this question. As far as motion in a straight line is concerned, we have the displacement s, we have the initial velocity, we have the final velocity, we have the acceleration, and we have the time, summarized as so that. Now the displacement, when we are dealing with motion under the influence of gravity, displacement is a vector quantity. Initial and final velocity, these are also velocity, they are both vector quantities. Acceleration is a vector quantity, it's only time that is a scalar quantity. So what does that mean? Because we are dealing with vector quantities, we are supposed to take into consideration their direction as well. All these are vector quantities. And by definition, we know that a vector quantity is a physical quantity that has both magnitude and direction. So it means that as far as this motion is concerned, you will find that this motion is first moving upwards. Then when it reaches maximum height, it changes its direction and it moves downwards. So it means that all that is going to change. It's going to affect the signs, or the signs of these quantities. Displacement is the distance in a specified direction. Now it means that if this is where you threw your ball from, this is your initial platform, it means that when you move upwards, our displacement will be positive. When you move downwards, our displacement will be negative. If we are talking about velocity, initial velocity and final velocity, if you're moving upwards, it means the velocity will be positive. If you're moving downwards, it will mean the velocity is negative. If we're talking about acceleration, now when it comes to acceleration, if you're moving downwards, it is positive. And it is positive because the force of acceleration, the gravitational force of attraction, acts downwards. So the acceleration is positive downwards, but when you move upwards, it means you're moving against the force of attraction or against gravity. So acceleration will be negative as you're moving upwards. So it means that in numbers like this, where the direction of the motion is changing, we will have to respect the signs on these parameters. Now, speaking of acceleration, because this thing is moving upwards, the acceleration is going to be negative all through. How? This is the explanation. Let's consider, let's say the ball is moving from that point to that point. So it's moving up. It means that here our initial velocity is a positive. Here our final velocity is also positive as it's moving from here to there, moving upwards. So what is the sign on the acceleration as it moves up? It means that our acceleration here, A, which is actually g, is going to be equal to final velocity, v, minus initial velocity, u, over the time. So final velocity, which is positive, minus initial velocity, which is also positive, over time. And you'll find that the acceleration you're going to get here is going to be negative. Why? Remember, as you're throwing a stone upwards, the higher it goes with its speed reducing. Its velocity keeps reducing until it reaches 0. When the velocity reaches 0, then it comes back down. So it means this initial velocity, if it is 10, the final velocity will be less than 10, because as it's moving up, its speed is reducing. And so because its speed is less, it means that here our final v is a small number minus our u, which is a bigger number. So definitely the answer we are going to be getting here will be a negative answer divided by time. So our acceleration will be negative. And that's why we say that when acceleration is moving upwards, for particles that are under the influence of gravity, the acceleration is negative g for a particle moving up. Now let's look at it when it's coming back down. Remember, it has been moving up, positive velocity, then it's coming down. Let's take a case in point. We're having that point and that point. As it's moving back downwards, we're having the final velocity here and the initial velocity there. We are considering this motion that it's starting from here, coming back to down here. Our initial velocity here is negative, and our final velocity here is also negative. These are negatives because now they are moving downwards. The direction has flipped. So what is the sign of our acceleration? We know that acceleration in that case is going to be equal to our final velocity, which is negative v, minus our initial velocity, which is negative u, divide that by t. And of course, this negative and negative becomes positive. We'll remain with negative v plus u over t. And we shall end up with our acceleration. Is it going to be a positive or a negative? Now let's analyze this. As this particle is moving from here and it's coming back down, yes, the velocities will be negative because now the motion is moving downwards. But remember, as it's coming towards acceleration, its speed increases because now it is being pulled by this force of gravity. Previously, as it was moving up, its speed was reducing because the gravity was pulling it downwards. So its speed was reducing until it became 0. Then it starts moving down. Of course, as it moves down, the lower it moves, the higher the speed. The speed keeps increasing. So it means that this value of v here is going to be higher than that u. that value, the velocity here is going to be less than the velocity here. So it means that here you're going to have a negative velocity which is higher plus a velocity which is low. Now let's say this was negative 30. This is 30 meters per second. If you dropped it off here at 10 meters per second, it's going to keep increasing to 30 and so forth. So you're having a negative number that is so large, and you're adding it to a small positive number, a small value of u. It means that if this value of v was 30, it's negative 30 plus 10. If this was 10, I'm giving an example. So it means that our overall answer here, whatever the figures will be, will always be giving you a negative. So that is why even as it is coming down, our acceleration due to gravity will always be a negative g. So that is why in this calculation, as we are trying to find the time taken for the ball to start from here to go up to down here, our value of g, the gravity, will be negative, because it is negative as you're moving up and even as you're coming back down. So with g, that is how it is. Our s, the displacement, will be positive upwards and negative downwards. Our velocities, if you're moving upwards, they are positive. If you're coming downwards, they're negative. And this is our point of reference. Now let's go ahead and start answering this question. The question is saying that the time taken for the ball to reach the ground. So again, we shall be using our equations of motion. It's going to be equal to ut plus a half at squared. Now our initial velocity is 14.7, so you have 14.7. Now initial velocity is positive, it's moving downward, so it's positive 14.7 times t plus a half times acceleration. Now our acceleration is going to be negative 9.8. I already explained where the negative is coming from. In the first case, it's even going against gravity. A negative 9.8 times t squared is going to be s. Now our value of s, remember they're telling us that what time is it, at what time, the time taken for the ball to reach the ground. So for this ball to move from here to go up and reach the ground, its displacement will be negative 19.6, because the displacement will be below this point of reference where it started from. So our displacement here will be negative 19.6. And definitely when we work out the values of t here, you're going to end up with a quadratic equation in t. T squared minus 3t minus 4 is equal to 0. We end up with our value of t being either 4 or t being either negative 1. So we shall take value of 4 as our answer. We can't have negative 1 as our answer, because we do not have negative time. Now looking at part B of the question, they are requiring us to find the velocity of the ball when it hits the ground. So when it moves, it hits the ground. Definitely as it's hitting the ground, its velocity is negative. So using v is going to be equal to u plus at. So the final velocity definitely is the negative v, because it's moving downwards as it's hitting. So negative v is going to be equal to the initial velocity. Our initial velocity is a positive, so it's 14.7. So it's going to be 14.7. The acceleration, remember, is negative 9.8. So it's going to be minus 9.8 times the time. Now the time taken for it to reach the ground is 4, according to our previous question. So it's times 4. So we go ahead and calculate. We're going to end up with our value of v giving us negative 24.5 meters per second. Now, of course, our this negative here simply signifies that the ball is acting downwards. So the velocity with which it hits the ground is 24. So a particle is projected upwards with a velocity of 34.3 meters per second. Find how long after projection the particle is at a height of 49 meters above the point of projection, for the first time and for the second time. So we'll summarize our question again. The particle is projected upwards with a velocity of 34.3 meters per second. So our initial velocity here is 34.3 meters per second. So find how long after projection. So they're asking for the time. How long after projection the particle is at a height of 49 meters above the point of projection. So this is the point of projection. So let's say this is 49 meters. This is the 49 meters above the point of projection. This is our point of projection. So after how long? So it means that as this particle goes up and comes down, you realize that as it's moving up, it will be 49 meters above the point of projection for the first time. Then it will move, reach maximum height, and probably come back. As it's coming back down, again it will be 49 meters above the point of projection the second time. So the question is asking us to find the time when it is there the first time and when it is there the second time. As simple as that. So again, our value of g, since it's moving upwards, our value of acceleration is definitely negative g. So we shall go ahead and say our displacement s is going to be equal to ut plus a half at squared. The displacement in question here is 49 meters. So 49 meters is going to be equal to initial velocity u, which is 34.3 times the time, that is plus a half a, our acceleration is negative 9.8 times t squared. When you rearrange this equation, you're going to end up with a quadratic equation, and that quadratic equation, so solving that quadratic equation gives you t minus 5. The roots are 5 and 2. So the values of time is going to be equal to 5, or t is going to be equal to 2. So to answer the question, it simply means that as this particle was moving upwards, the first time it will be 49 meters above the point of projection will be 2 seconds. So that answers part A. Then the second time it will be 49 meters above the point of projection is 5 seconds, and that answers part B. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.